So Project Blue Water, basically, as Rob said, it started as a pilot project. We worked with 35 growers between 2018 and 2020. Quite successful, so the project got extended for another 4 years. So we're working with an additional 100 growers until 2024 in June. So main things we're looking at is improving herbicide efficacy. So how do we get better use of our chemicals, essentially? When we start using things more efficiently, we ultimately reduce losses as well. So what's good for water quality is generally good for growers in terms of spraying as well. So that's really where we kind of target a lot of this stuff, is how do we get the best out of the growers' equipment with what they have. So first thing we look at is their application equipment. So if their application equipment isn't operating as it should be, or if it's not at 100%, then there's no point looking at any product application stuff or product choice stuff. So there's $2,500 available to growers for boom upgrades. So we do a full boom assessment where we look at pressures compared from the cab down to the boom, see if we've got any pressure drops. We look at what nozzles they have. Are they 2,4-D compliant? Are they doing the best job with Roundup? All that kind of stuff. So we look at nozzle spacing too. So nozzles are calibrated to operate at 50 centimeters spacing and 50 centimeters above their target. So as soon as you start monkeying with that, you can change overlaps and things like that. So if a grower's swath width doesn't match their row width, then you can also have problems with overlap. So if you're overlapping right on your row and you're applying something like Flame and you're applying a double dose, you're going to notice that. So we try and get everything right at the beginning, and then we've got a good piece of equipment to work with. So the next thing we're looking at is spray water quality. So spray water quality, it's the water we put in the spray tank is about 99% of what we're spraying. So it's really important. It's the carrier. So the main things we look at is our pH. So if we have really high pH or really low pH, we can have something called alkaline hydrolysis, where certain chemicals basically get blown apart before they even get a chance to get into the plant. So it was about 30% of the bores we tested were above about 7.5. So it's no secret that the Burdekin has got alkaline soils and alkaline water. So that's something that we consider too. So everyone that's using a bore, we get a water test for. So next thing we look at in the water is hardness. So hardness is basically, and you add up all the amount of positive ions in the water, and they can basically grab onto things like glyphosate, and they can pull the charge out of it before it has a chance to actually get into the plant. So it does what it's supposed to be doing on the plant, it does that in the spray tank with the calcium ions. So what we do is look at the hardness, and then we also can add ammonium sulfate. So ammonium sulfate, we add that to the spray tank, and then that can actually pull out those calcium ions before the Roundup has a chance to be deactivated by it. So that's just one of the things we're looking at. The sleeping giant is an issue called bicarbonates. So bicarbonates is a problem for things like 2,4-D amine, so Amosite Advance, if anyone's used that before. So basically, bicarbonates will do the same thing that hardness will do for Roundup, except for 2,4-D. So, and things like Group A herbicides like Verdict and Select and Platinum Extra, those kinds of alternative crop herbicides. So over 56 to 60% of the bores we've tested have had bicarbonates that are above a threshold that we're happy with. So there's not too much you can do about high bicarbonate water except change your water source or change the chemistry you're using. So that's the second thing we're looking at, is the spray water quality. So third thing we're looking at is pesticide management planning. So mainly focusing on herbicides. So looking at what weeds are growers dealing with, what residual herbicides are they using, what knockdown herbicides they're using, what mode of actions are they using. So how do we get on top of the problems that they're dealing with, the chemistry that they've got available to them, basically. So so they're fully spatially mapped, tailored plans as well. So last thing we're doing is offering growers the opportunity to go to advanced spray application workshops, so trying to upskill growers in that area a little bit. So looking at droplet selection, nozzle sizing, water rates, chemical rates, all that kind of stuff. So I'll start off with our demo here. So this is our little blue water demo boom here. All right, so what we really need to focus on is getting the chemical to where it needs to be. So if we talk about different chemicals and where they need to be, we've got certain chemicals that are systemic, meaning that they'll basically touch a small part of the plant, they're absorbed and they're translocated. So Roundup is an example of that. Chemicals that are contact, so basically they'll touch whatever they'll kill whatever they touch essentially. So coverage is really important. So things like gramoxone or paraquat, really essential to get really good coverage. So when we start talking about different coverage, we talk about different droplet spectrums. So just pass me that one there, Chris. Sorry, that one in your hand. That one there. Yep. So kind of ignore these colors here, but these are our droplet spectrum. So we've got extremely fine, very fine, fine, medium, coarse, very coarse, extra coarse, and ultra coarse. So those correspond to certain sizes along this side here. So basically, if you have a droplet that is less than 150 microns, it can't fall to the ground under its own weight. So anything where we have fine, medium, getting sort of into coarse here, we've got potentially 20 to 40% of the droplets can't fall to the ground under their own weight, which basically means that 20 to 40% of the product isn't getting to where you need to get. So have a look at this one. So we've also got a few different types of nozzles available to us. So we've got nozzles called pre-orifice nozzles. So these kind of short ones here, I'll pass this around as well. So this is called a pre-orifice nozzle, meaning that it has no air induction. So it's basically just got a hole at the top and then a hole at the bottom, just forces water through, and that's how it creates its droplet spectrum. So they've got optimum pressures when you need to run these different nozzles as well. So a pre-orifice nozzle, an XR flat fan, so that's a DG similar to an XR, it will be producing potentially 41% driftable fines at 3 bar. So we've got pressure in a spray tractor, we've got pressure, we've got speed, and we've got water rate. So they're generally the 3 aspects. So pressure is very important because that's going to determine what your pattern's going to be. So if we have a look at these nozzles here, this one and this one, so I'll just turn this on for a second. And just adjust that pressure. We'll get it to about 3 bar. Keep going. All right, 3 bar, there we go. All right, so as I said before, these are calibrated to be 50 centimeters apart and 50 centimeters above their target. So at 50 centimeters apart, they're producing a total overlap, a 50% overlap on each side here. So that means you've got full rate across your boom. So if we start talking about these different pressures we're supposed to be, is everyone getting a bit of that drift there? Yeah. So that's coming from our pre-orifice nozzles here. So this one here producing a fine droplet, and this one here producing a medium droplet. So we've got potentially 41% of that is hitting you guys. That's not going where it needs to be. So if we move into these low pressure air induction nozzles, so this is an AIXR here, you're gonna have a little less drift because obviously we got it covered there, but still 16%. So this is a pretty common nozzle here in an O2 size. So also similar to a Hardy Mini Drift as well, if anyone's heard of those. So 16% of that can't fall to the ground under its own weight. So we start talking about boom height and moving boom height. So how many growers do we have here? We got, do any spraying, Brian? No. Anyone do any spraying? Yep. How high would you normally run your boom? High enough to clear obstacles, yeah, all right. So would you normally be running your boom at that height there? Close to it? Yep, so that's 50 centimeters there, so we're at about 90 centimeters here. If we move this up to, say, 75 centimeters, you increase your drift potential by 4 times. So moving that height there. So we need to be basically 50 centimeters above the first thing we're going to hit. So if that's plant cane, we're 50 centimeters above that, and then we've got another 50 centimeters of plant cane, we're a meter off the ground. All of a sudden, all these things blow out here. So getting your droplet spectrum right is really crucial. So if we move into these high pressure air induction here, so low pressure air induction, we've got that one there, Chris. We'll just, so as I said, we've got optimum pressure ranges. So 2 to 3 bar for these ones up here. My little boom's not capable of doing 4 to 5 bar, so we won't see that example today. But when we move to these low pressure air induction nozzles here, this one and this one, optimal 3 to 4 bar. They will run at those lower pressures and those higher pressures, but that's when you start blowing out all of this. So getting that optimum pressure correct is crucial. moving to these high pressure air inductions, if you run these too low, their fan angle collapses completely. So you no longer have that 50 centimeter overlap anymore. You potentially move it down and you don't have that 100% of product moving across the paddock. So high pressure air inductions, we want to be running those in that 4 to 5 bar range. So if we are upgrading nozzles, we need to be taking into consideration these high pressure air inductions. So we might be running out a bit of water there. Just turn that one off, yeah. If you just want to open that one of those two valves there. Yeah, yep. And they should come back on. And then that one as well. Yep. All right, so where were we? Yeah, so we'll move on to wettability. So different weeds have different wettability. So Brian, would you say you have issues with Rhodes grass? Killing Rhodes grass? Hard to kill compared to... Not really? Where's Ryan gone? Rhodes grass? Hard to kill? Yeah, he probably got the right nozzles. Yeah. So, Rhodes grass, probably one of the hardest weeds to kill that we have in the Burdekin here. The reason is it's got quite a furry leaf surface and it's also got a really hard angle to attack. So, if we start talking about different droplet sizes and these high pressure, low pressure air induction nozzles, these pre-orifice nozzles, generally we talk about coverage. So we want really fine droplets, really small droplets. So got just a demo I've done here. So that's a fine droplet. This is on water sensitive paper. So basically I just did it with a little demo boom. So that's 220 litres a hectare. Would you say that's pretty good coverage? Be pretty happy with that? Yeah? So use something called Snapcard, or there's another app called, what is it, Smart Spray. So basically we can use our phones to work out how much coverage we've actually got there, or estimate the amount of coverage. So 35 to 45% is the coverage on that fine droplet right there. It's not great. Yeah, so the problem that we have is that we're potentially losing 41% of the product. That's why we don't have that really good coverage, because we're losing a lot of it to that. That's at 3 bar. So we would have that 40% driftable fines there, 40% of the product not hitting the target. So would you say that's good coverage? Would you say it's better or worse than the other one? Better? Yep. Well, you bang on. So 50 to 65% coverage on that one, because you're getting all the product to the ground. Because we're using something like this, a TTI, which is these ones down here. Just want to turn that back on, Chris. Takes a little while to get back up to speed. Yeah, keep cranking that pressure. Oh, back again. Yeah. All right. So we'll move down to this one. All right. So we've got a TTI there, also producing an ultra coarse droplet. Then if we move that to, where will we be? To a fine droplet. Ultra coarse, not getting hardly any drift on my fines, drift all over the shop. So the product's not hitting the ground basically. So these pre-orifice nozzles are actually leaving the nozzle 40 to 50% faster than a high pressure air induction nozzle. So they've got a lot of punch. So that means they're really good at penetrating a canopy. So if we talk about maybe fungicides or insecticides and we're trying to penetrate a mung bean canopy, we don't want something soft. We don't want something that's going to sit on the top because our infection is down low. So we use those punchy nozzles, so those pre-orifice nozzles, to get into the canopy. So where we want something to wet, like Rhodes grass, we want something really slow. We want something really gentle, just to kind of hit the leaf and then just slow down and then really sit there. That's where these twin angle high pressure air inductions are perfect for it. So you're getting all the product there, and you also don't have the drift there too. So you can control your drift if you're potentially spraying in not subpar conditions, but when it gets a little bit breezy, so when it gets above that kind of 15 k's an hour with 2,4-D. So really good roundup nozzle. And a really good nozzle for wetting, so for actually wetting things. So, all right, so we'll move on. what's next? We'll just talk about some urban leg legislation. So these legs here. So we're talking about droplet spectrum. Probably about 80% of the spraying we're actually doing is being done with an urban leg. So generally ratoons in crop spraying. We basically have to comply with some 2,4-D legislation that came in 2018. We need to produce a very coarse droplet. So do you have those sheets again? Well, I did them over there. So we need to produce a very coarse droplet. So remember we had fine, medium, coarse, very coarse, ultra, extra coarse, ultra coarse. So those very coarse droplets, basically we're mandated because we're not allowed to produce drift with them. So in 2018, the cotton industry, I think it was about $75 million worth of cotton damage due to drift. He drifted 70 kilometres away. And basically the entire agricultural industry got wrapped up in that legislation, and we had to comply with it too. So generally on these urban spray bars here, we're historically using these pre-orifice nozzles. So these pre-orifice nozzles producing medium to fine-ish droplets. So there's no longer we can use 2,4-D through those basically because they're producing those too smaller droplets with too much drift. So the problem is, well, the easy part is you could just put an air inducted nozzle. So put something like one of these straight on there and that would solve your problem. But they block up. Within first pass, they block up basically because these are injecting air. So they're sucking in air. And what else do they suck in? They suck in dirt and seeds and just crap you don't want in there. So they block up almost immediately. So what we were doing was moving growers toward these flood jet systems. So this twin flood jet here, it's not air inducted, it's got about 140-degree fan angle. One of the problems, is that working? I just want to turn that on. I don't know if we'll get the pressure out of both of them. All right, turn that, yep. So you got one flood jet facing forward, one facing backwards, producing an extra coarse droplet at 3 bar. So that's one of the easiest conversions. It's not cheap though. It's $250 for this whole assembly here. If a grower's already got an urban spider system, why would they want to go to something like this? They don't want to reinvent the wheel. Up until December last year, there was basically no option to get a nozzle that would fit these urban spray bars that we could get a 2,4-D legal droplet out of. So a company called ARAG in Italy actually developed these specifically for the 2,4-D legislation, these nozzles. So these will produce an extra coarse droplet at 3 bar. It's about $11 a nozzle. So for 60 bucks, you can become 2,4-D compliant and you're not going to compromise on the job you're going to do as well because you're still using the spider system as well. So, all right, that's pretty much most of what I wanted to show. I'll show a few different types of flood jets here as well. So just turn that one off, Chris. So there is a couple of different types of flood jets that growers need to be aware of as well. So there's something called a TK flood jet, which is this little number here. You might. So this here is a TF flood jet. So they differ by one letter, but they produce completely different droplet spectrums. All right, turn that on, Chris. We'll just get that to like 3 bar. Good? Yep. All right. Yep, bring it back down to 3 bar. All right. So, you're getting soaked there, aren't you? Pretty well? Yeah. So, not 2,4-D legal, 2,4-D legal. I've seen these in the same bin at spray shops. So, just something to be aware of if people are moving to these flood jet systems, that sometimes the spray shops don't really even know the difference between them. They didn't have a droplet spectrum for this one until 2018 either. So, it's nobody's fault. It's just the fact they didn't have a droplet spectrum for them. So, now we do. And there's not really a use for these anymore. So yeah. All right, that's pretty well it. I'll show you some of these. Yeah, I'll show you some of these AIUB nozzles. So we'll move that one there. Take that off. All right, so does anyone do any band spraying or shielded spraying or anything like that, or have done in the past? Yep. So these are an air inducted AIUB nozzle. So generally, a nozzle is 110 degree fan angle. So 110 degree, basically straight like that. These are offset. So perfect for band spraying. All right, you want to turn that one on? So you can see they're kind of offset. Well, we've got them on, that one's on the wrong way. Turn it off, mate. So orientation is really important with these as well, because otherwise you'll be spraying the completely wrong thing. All right, turn that on. Have the section on me right, eh? All right, so imagine we've got a shield here, spraying Roundup in the drill, and we've got a shield here, spraying Roundup in the drill. This is our plant line. This is our mung bean arrow soybean plant line. So wherever we're going to be applying insecticides, we don't need to be applying them in the drill. We don't need to be applying fungicides in the drill because that's not where the infection is. So a really good option for band spraying, and also for the ends of booms as well. So where we've got growers that have bought booms that maybe they were on 1.6 metre spacing, the previous grower, they're at 1.5, their overlap's going to be completely out. So we can control that with these different angled nozzles. So you have one on each end, and all of a sudden your overlap is completely different because you control it with your angle without having to replumb anything. So, all right, that's pretty much all I wanted to show you guys. Feel free to come up and have a look at like the different nozzles we got and ask questions, that kind of thing. So we've got those water sensitive paper over there too, so you can have a look at that. But is there any questions or anything, any of the nozzle stuff? Not really?
How many setups do you need to operate a cane farm?
You can get away with one boom, but probably 2 to 3 sets of nozzles.
What about legs?
So that's included in my 3 sets of
legs and a flat boom.
Yeah. So flat boom, we need a pre-emergent nozzle, so maybe an 05, so a brown nozzle that's going to produce our 250 litres plus. It's going to paint the ground basically. That's when we want to be using those ultra coarse droplets as well, because we don't want 40% flying by the wayside, you want everything on the ground. Then we need a Roundup nozzle. So our Roundup nozzle capable of doing about 100 litres, no more than 100 litres with Roundup. People think that once you get a bad Roundup job and you up the rate, you're going to do a better job. You're not. So what you're going to do is actually wash out your Roundup. So you want to have as much Roundup concentrated in a droplet as possible. So a high water rate in broadacre, so all those cotton guys we were talking about, a high water rate for them is about 70 litres. So they're applying pre-emerge at 70 litres, and so water rate's not really our problem. But Roundup, that's probably a good take-home point, is you don't want to be over 100 litres for Roundup pretty well. So, and get your wetters right as well. So let's talk about wetters, talk about Gramoxone 250. It's got the wetter package built in. It's got the wetter package built into about 100 litres, and we're applying it at 300. So that's not enough wetter, basically, for the amount of Gramoxone that we're applying in that water. So we need to be adding more wetter, potentially, to that, because they were not expecting us to do 250 litres a hectare. So Roundup nozzle, pre-em nozzle, and then we need our legs, and a leg nozzle capable of doing 250, 250 plus. So but if we can get that application method right, like the droplets, how fast they're going to hit things, then we're going to do a lot better, I think. So especially when you start talking about verdict and things like that, so alternative crop herbicides where coverage is really important. So, but we want to get it all there. We want to get all the chemical there. So we've got to find that line between decent coverage and getting the right wetter package as well. So yep. All right. We also still have some spots available in Blue Water. So there's about 10 to 15 spots still available that we can start working with guys within the next 6 months as well. So if anyone's talking to anyone and wants to have a look at this stuff and isn't happy with their spraying equipment, thinks they're doing everything right, but maybe they've had a bad spray job, that kind of thing. So we can help with that. So thanks very much, guys.
How does a grower when you finish the project and leave that grower to their own devices, how do you know that there's legacy, that the information that you've put across to them is going to be something they're going to be able to refer to regularly?
Yeah, so in that pesticide management plan that we provide them, we've got basically everything that I've talked about in that. So we've got all droplet spectrum charts, everything that they need to refer back to. We've got every single product registered in sugarcane, what droplet spectrum they should be using, what water rate they should be using, basically the deconstructed labels, everything that's important out of a label, everything's important on a label, everyone read your labels. everything that's important in terms of application with incorporation method, everything like that is all in the pesticide management plan that they're getting. So that's the legacy basically there.
So the upsell for growers is they're getting really good efficacy out of what
Yep.
they put on. They're not wasting their time spraying something and then having to go back and do it again. They're getting good outcomes. What's the water quality benefit? How do you achieve that?
Water quality benefit. So if we start talking about optimizing rates, so if we're talking about potentially losing 40% in driftable fines and we can move that back to we're not losing 40% driftable fines, then we can start tailoring where our rates are. So if we're putting on 5 litres of Roundup, do we need to be putting on 5 litres of Roundup? Can we do the same job with 3 litres? When you start talking about residual herbicides, we shouldn't be reusing residual herbicides just because it's going to save us time throughout the season. We should be using residual herbicides in response to situations to get on top of situations and then managing things with knockdown. So that's the kind of thing that we're working towards in the pesticide plan. So what's the grower doing currently? What have they done in the past? And what problems do they need to get on top of? And if we can kind of pull that residual use back, which generally is where the water quality benefit comes, that's where we're going to get the gains. Also in the product selection as well. So if we talk about a simple plant cane spray, a grass spray, something like Dual Gold or S Metallochlor is the active. We talk about Stomp Extra. Stomp Extra will not move from a paddock. You need to lose soil basically to lose Stomp Extra, whereas Dual Gold is highly soluble. So you'll have more losses in terms of water quality. You have far more losses with Dual Gold than you will with Stomp. And they're comparable in terms of their efficacy. Stomp does generally a better job in most situations that we've found if you can get it incorporated correctly. And you don't lose it as well. So yeah. All right, anything else?